Okay, hi everyone. Welcome to the Code for Kids section of Google Hangouts on Air. We're very excited to be here today, and I'm very excited to share Code for Kids with you and what is happening in the coding world in education. So we've had a few technical glitches. So Anthony's in now. Anthony, can you
Yep, we're hearing you okay. Yep, welcome everybody to this session.
Yes, so I was just saying we're having a few technical glitches, but it seems that things may be working now. So let's get started.
Kelly, how about you go ahead and share your screen and we'll put up the slides. We'll see that's working. And I'll introduce you, Kelly, while you're doing that. So Kelly, today we'll be talking about Code for Kids. Kelly is a Google for Education certified trainer. She's passionate for learning and teaching with digital technology. Currently, Kelly is working with the Catholic Education in Melbourne, and she's working as an icon implementation coach, supporting schools with G Suite for Education and digital technologies. Prior to this, she was teaching in years 3 to 6 as a contemporary learning and digital technologies leader. She is a GEG leader of our cohort here in Melbourne, and she has started her own passion project called Code for Kids, which essentially, Kelly, that's what the nature of today's presentation will be about.
Okay, great. Thanks, Anthony. Can you see my screen there, Anthony?
Looking good for me.
Yep. Okay, so I'm just going to put this on present. Okay, so as Anthony said, I've started a little passion project, I like to call it, called Code for Kids. I was doing Genius Hour with all my students at school, and I thought I really want to do something for myself, and so this is what I've done. So essentially I've created a community called Code for Kids, which started with Google+, but has now turned into webinars and also a website to help support teachers. If you need to, you can actually grab the shortened URL down the bottom, and this will actually take you to the slides, so you can make a copy of these for yourself if you'd like to share this on in the future. So just a quick agenda. We're going to just go through a quick introduction, a bit about the curriculum, looking at why we would teach coding in schools, so all about future careers, bit about digital literacy. I've got some ideas and resources for you as well, and also some information at the end about how you might, if you wanted to become a certified educator, what process you might go through. So I might start just with the curriculum. So in Australia, the digital technologies curriculum needs to be mandatory reported on from 2017, so next year. So this was introduced through the Australian curriculum, and then governing bodies in different states and territories actually went ahead and created their own curriculum based on the Australian curriculum as well. So this circle tells us a lot about the curriculum. So it has in the middle about creating the solutions. So it's all about problem solving and creating solutions. But to do that, we can go through a few different processes to meet that. So partly we have digital technologies and design technologies. And within that, we have sitting around that, the computational thinking and design thinking sort of overlapped in those areas, with computational thinking sitting more in the digital technologies area. And systems thinking really encompasses both of those things as well. And we can see that, this can lead into project management and creating preferred careers. When we talk about design and technologies, we might look at things like maybe the need of a social aspect. If you think of the coming of Facebook and Twitter and things like that over the last decade or more than that, actually, that's all about the design thinking, design and technologies, and they saw a need for that, and they created those social media platforms. And there's things like Snapchat have been designed more recently. But the digital technologies comes into more the algorithmic thinking behind it as well. So when students or when programmers are creating websites and things like that, they're using more digital technologies curriculum. So there's lots of different people out there that are using code in their careers, or trying to come up with ways to bring digital technologies into their jobs. So I think these were three examples that I really enjoy listening to. So Trisha up here, she designed a program that she put onto the libraries in her area, and they when people got on there to post on social media, the program actually sort of made them think about what they're going to post, and did that think before you post mentality, where they actually got on there, and if they wrote something that was not very nice, then the program would pick up some of those words and through using some algorithms, and would say, this doesn't sound like it's going to be a great post. Do you really want to post it? And then it makes people actually rethink what they're going to put onto social media. And they found there was about a 95% rate of success with people actually not posting things that they had originally written. Brittany actually down here, she and these two are both Google Science Fair contestants. Brittany actually designed an algorithm to help detect early onset of breast cancer, which is now being further looked into into breast cancer research. Over here, Fran actually works a little bit with Khan Academy, but is actually a designer for Disney and Pixar, and she actually designs clothes that some of the characters may wear in some of our very famous movies. Like in Brave, she designed the clothes that the female characters in. She also designed things in Monsters Inc. in the beautiful animation Up. She designed some of the things in that as well, some of the clothes in that as well. And she talks in there about the importance of using code and how this comes into art as well. So we hear a lot of this buzzword, digital literacy. And digital literacy has become a very big buzzword in Australia at the moment because of all the digital literacy grants. But when people were applying for these grants, I did notice in some of the communities, some people just didn't really understand what digital literacy actually meant, or what it encompassed. So I found this quote. I read in a blog post. It was published by the American Library Association Digital Literacy Task Force, and I thought this really was a really good way to think about digital literacy and what it encompassed. So digital literacy is the ability to use information and communication technologies to find, evaluate, create, and communicate information, requiring both cognitive and technical skills. Digital literacy is no longer just reading from an iPad. It's no longer just reading from a computer. It's actually using the information, the digital information that people are getting, and actually doing something with it. It's using it for communication. It's using it to evaluate. It's using it to problem solve. It's using collaboration skills. So all these things are included in digital literacy, even though digital literacy it's only one part of it's actually sort of the bigger part of using digital technologies, because if we don't have that digital literacy of being able to use these skills, then our digital technology skills probably won't advance as far, because we're not using all these other skills built into what we need to do to get to where we need to get to. So I really liked this, and I can't remember where I got this from, except I remember where the credits were. I don't know if I found it online, or I might have even found it when I was doing one of the University of Adelaide's, one of their MOOCs. So this digital literacy, this is just a breakdown, the computational thinking. So digital literacy skills is what encompasses everything about digital technologies, really. And then under that, we have the computational thinking, and then the coding. So the coding is just a part of computational thinking. It's not the whole part of computational thinking. And if you listened to Tim Bell before, you would have heard him talk about the importance of the unplugged activities to develop those computational thinking skills. The coding is one small part. If you look into the curriculum, it actually in the Australian and the Victorian in particular, it actually doesn't say coding in it, but it actually implies that you would use coding to develop the computational skills by looking into into programming environments. So coding is a way we can achieve the curriculum, and that's why it's a big buzz thing at the moment. And there's many different ways you can use coding to achieve the curriculum. It's just it's not the only way as well. So it's really important to have that really good balance that students can see that when they're learning about coding and computational thinking, that they actually start to think beyond just using the computer. Very recently, a colleague of mine's daughter, she actually won a competition with Little Big Ideas where she designed a Band-Aid contraption, and the Band-Aid contraption actually was a design that she drew. She didn't actually do any coding, but she actually does a lot of coding at home as well. And in this coding that she does at home, she's actually been able to learn how to use the computational thinking skills and problem solving. And she's actually, as a part of that, she was 1 out of 900 students, and she's actually going to be going to NASA Space School as a part of winning this competition. And they're looking at getting prototypes made up of her design, because she found the need that in hospitals, when people wear gloves to take Band-Aids off the paper, it's actually really challenging for nurses to do this. So she thought that there has to be a better way. So she designed something to help that. So where might you start? So if you were starting to implement code into your school and you've never done it before, then there are some steps you might take. And these are the steps that I have taken when I have worked with coding. So I'll always start with some unplugged activities, because it really helps to build vocabulary of the actual language they're going to have to use, introduces concepts, and helps the students cope better going further down the track later, because they haven't built this understanding. So with the after you do some unplugged activities, you may start using some visual programming environments. And when you're using visual programming environments, these environments really are most of them are self-paced, and you can sort of learn with your students if you're not sure as well. And it helps to then take the unplugged skills and concepts and language and put them into this environment. So then this helps students to become very familiar about how computers work and systems work, and this brings in that systems thinking. Then you might take a visual programming environment, and if the students have really been able to really confidently get those concepts, they can move into more complex environments where they're actually using more coding language. In the visual environments, they use a lot of block language, where they're shifting blocks and putting blocks in different spaces. Like in Scratch, you'll see the blocks move over to make the characters do things, or in code.org. But in more complex environments, it takes away those blocks, and you actually have to use the language that a computer would need to understand. So sometimes when you do in code.org, you might actually do an activity. You actually then can press at the end, show the code, and you'll actually see the code that you have written by doing the activity. So this, in the more complex environment, actually you write that code. So you're not putting the blocks in and then seeing the code, you're actually writing the code. And there's a few programs out there that can help that to happen. So it's, again, using the language, and it's also students will get full functionality of the programs. Then once they've done that, they may like to think about how they might make a difference. So what I like to do is get students to think about, okay, I can now code, I can now problem solve, I have built on my computational thinking skills. Now finding that need and creating a solution. So developing, so you may or may not use the coding, but you are definitely using the processes that you took to do the coding to develop a solution. So there's many different out there. There's lots of competitions even that students can enter to go into actually put their designs in to develop a solution for something a need that they've seen. So some ideas going forward. If you haven't already heard Chris Bell talk, he talks about CS Unplugged, which is a website that is his baby almost. And this website is really, really great one. It has lots of different activities on it, and it actually breaks it into the different areas of computer science. So you can look at if you want to focus just on algorithmic thinking or design thinking, or if you want to focus on some aspects of computational thinking or binary. There's different activities in there that can help. Code.org also have a whole computational thanking unplugged activity area as well. So if you click on any of those pictures, that will take you to those. They actually would help to go further with some unplugged activities and be able to build the skills of the teachers as well, because I think part of this curriculum coming in is that teachers are a little bit afraid that they don't know this and they don't know computer science, and it's this big thing that they have to go and learn. But really, they're probably already doing a lot of these things, but we just got to call it out. We've got to call out that we're doing it. So some visual environments that students can use. There are some pretty more basic ones, such as Run Marco Run, Code Club Australia, Code.org, Made with Code. All those websites are pretty easy to use from even at a prep level. Made with Code may be a bit older, and I really like Made with Code because it actually really incorporates a lot of the maths curriculum. I was actually able to teach a whole unit on Cartesian coordinates using Made with Code. So there's a lot of different environments out there. Blockly is a really good one to start with as well. Blockly here. If you're using, this CS First is a Google initiative, and it's really great because it has a learning management system behind it, so you can actually see where the kids are at and how they're going, and really help them through. And it actually has also different. You can set up a program to meet a different need. So you might have students that are really interested in art, so you can actually put a program in that's more art related or storytelling. So these actually can be very differentiated, and you can set up multiple ones in your class. Pixar in a Box is a really great one, and this is part of Khan Academy. If you like Khan Academy, you'll love Pixar in a Box. It's a really challenging one. It more for grade sixes, even secondary schools. This one, so one of the activities that I was working through on there was looking at how, if you've seen The Good Dinosaur, these are people that they had people on there that talked about how they designed the skin for the dinosaur and what they actually did and the plants that they actually studied to get the different sort of scales and bumps and that they could actually incorporate into their own design. And so then part of the actual activities is to then recreate those actual designs as well. And so they actually teach you how to do that using the coding language, and it's a very language-based Pixar in a Box. It talks about a lot of language that I'd never heard before. So it was really good learning for me. It's a really good one, but this language is very complex in it. So it is for older students. But kids love it because even in one of the actual tutorials, it teaches you how to even, like in Monsters Inc., how it moves the fur on the monsters when they're walking and the fur is moving, and you can see that when you watch the movie. But in this one, it actually shows you how they actually just move one piece of fur, and it's really interesting to even just watch. A few iPad ones, Daisy the Dinosaur and Hopscotch are really good iPad ones, and we've also got Scratch there, and Scratch Junior is really good as well. Goldie Blocks is a newer app. So Goldie Blocks is based on trying to get more girls involved in coding, and these actually Really great. My 4-year-old loves this one. She rides a skateboard around and she collects cupcakes, and you have to tell her where to go. And this is actually how my 4-year-old daughter learned to use arrows. So it's really, really good. They're a really good one. There is a small cost in the Rocket Cupcake one, but there's another one which is a Movie Maker one, which looks at how to create animations. If you remember back in the old days when you used to draw a little stick figure and then move it a small piece and then move it a small piece and move it a small piece, and then you flick through it in the book and it moves. So this actually is based on that concept, believe it or not, but really good ones. This one is actually free. And so there's a few there as well that you can explore. Okay, so if we want to go a bit further, there are a few things that you can do with your students to go a bit further. So you've got Tech Girls Movement they have a search for the next Tech Girl superhero, where students create applications that will make a difference to the world. So it's a really good one for problem solving and finding that need and creating a solution. The ASAR video game challenge is another good one. Screen It with ACMA is another game-based competition. And that's also the Google Science Fair, which happens every year. Some resources for you to take away. This is the website that I have created, and I'm actually just going to show you this one. And when you go into this, you actually can go into different areas that you're interested in. So if you're a junior school teacher or a middle or senior, or you just want to look at code clubs, you can go into different areas there, and then you can see what sort of activities there are. And what I try to do is give you resources, links, and also linking it to some cyber safety and into the curriculum. So this links into the digital technologies curriculum for Australia, because based on Australia, so you'd be able to fit this into your own context. You also have links here to just key concepts in other areas. So if you're doing this activity, you would actually meet all these actual curriculum outcomes. So there's lots on here that you could go through and have a look. And there's also all the webinars that we run are up here as well. So you can see any webinar, go back and have a look at those with resources, and also professional reading. But we've also just recently introduced an unplugged section. And in this section are activities specifically that are unplugged activities where you don't actually need to have a computer to complete the activity. Okay, so that brings us to the end of this presentation. I'm just going to show you, there's my details if you need to contact me. Don't forget you got the bit.ly down the bottom with the actual presentation there. And at the end here, there's some information about how you might like to become a Google certified trainer or innovator, and the steps, or educator, and the steps that you might take in doing that as well. So, Anthony, have you seen any questions come up, Anthony, that we should address there?
Sure. Well, first of all, shout out to Karen Thompson and Audrey Ney, who on Twitter have said that they've loved the idea of unplugged as a first step, because that really does build teacher confidence. So that's resonating quite well with people, and I would tend to agree with that, because you know, if you want to really try and unpack this idea of sequencing or algorithms or programs, you can really do that by unplug, so that your teachers get confidence to move forward with that. So that's great. There was a specific question in the Q&A. Fiona Holland saying that she has an issue using Scratch on iPad, that it asks for Adobe Flash. Is there a way to get around this other than using the Scratch Junior app? So I'll probably think what's happening there, Fiona, is that you're probably using Scratch 2.0 on the iPad, and as the iPad can't run Flash, then you'll have a problem with that. So Kelly, really as far as iPad's concerned, Scratch Junior is the only way to go with that, correct?
So you could use Scratch Junior, but you could also use the other some other apps that I showed you, if you wanted to sort of move away from Scratch and try some other things as well, Scratch is really great on the computer. Scratch Junior really would be the only Scratch for the iPad that's good in the Scratch environment. But there is the Daisy, the Dinosaur, and Hopscotch, and the Goldie Blocks, and there are quite a few others as well. And Apple have actually released their Swifty environment. Now, I haven't actually used that yet and experienced it, but that's a new one as well. So there's a few other options there if you had just an iPad environment in your classroom.
Excellent, great. I don't think there was anything else. Look, I think, Kelly, one of the things that you mentioned in your presentation when you had all of those different coding applications up is that we're really spoilt for choice when it comes to this. You know, to me, this is not really one of the challenges per se, because we've got access to so much that we can be using. But what, in your opinion, do you think will be the biggest challenge or obstacle to adoption in your role as a leading teacher in implementation when it comes to the curriculum? What, in your opinion, what do you think is the biggest challenge for people? And your passion project, Code for Kids, how can that help?
So I think the biggest challenge is building teacher capacity. So I think teachers are a little bit unsure about, you know, there's a bit of panic about having to report on this and being a bit unsure about what computer science actually is. I started the Code for Kids after I actually completed the University of Adelaide's, the MOOCs that are actually run through there with Rebecca. And the idea came really as a part of has built from that, because I found in the community that there was so much unsureness and so many people aren't like just really having a go and trying. And so when I thought, oh, I'll just create this, I'm going to create this environment and see how it goes, because people obviously want those resources, they want more. And so that's how this is sort of eventuated. And then to actually then give them a website has been really valuable for them. So I think, you know, start small, start with one thing. Even if CS First is a really good one to start with, it does use the Scratch environment as well. So it is a lot better to use it on computers. But it's, you know, just start with one thing. You know, we try and give you lots of things, but start with one thing, choose one thing. It may be just an unplugged activity that you do this week or next week, and that may be the one thing you do for the rest of this year. To build your confidence, because that's what teachers need to do. We need to build our confidence to move forward in this environment.
Yeah, really, really sound advice. I think we're pretty much almost on time. So, Kelly, we might leave that there. I'd probably also suggest that a good place to start for people, particularly in Australia, would be the Digital Technologies Hub.
Yes.
You know, I think that combined with, you know, the Adelaide MOOCs, what's coming out of that, resources like Code for Kids, there's plenty of things on our radar that we can tap into to really get this moving in 2017. I know it's high on the priority for a lot of schools. So I think what you're doing in this sphere is great, Kelly. Thank you so much for presenting today.
Thanks for helping, Anthony.
Yeah, no problem at all.
Okay, well, thank you. We'll see you later. Thanks, everyone, for watching.
Bye, everybody.